In this question, we're asked to reorder these so that the atoms are in order of decreasing size. And decreasing size means biggest first. So if you're ever asked to put things in order of increasing or decreasing, whatever, just one good question to ask yourself is, does that mean biggest first or smallest first? Well, if it's decreasing size, you want them to get progressively smaller, so you want to put the biggest one first. So if we look at our periodic trend, we have a periodic trend for increasing atomic radius. And it goes down and to the left. So essentially helium is the smallest and cesium or francium, whichever, is the largest. Okay, francium is bigger, but it is a man-made element. But as you go down and to the left, they get bigger. So as you move left across the periodic table, atoms get bigger. As you move down the periodic table, atoms get bigger. So in the first case, we have silicon, magnesium, and argon. So here I have a periodic table. I have silicon, magnesium, and argon. And you'll recall that I want to place them in terms of decreasing size, so biggest first. So if we look at our trend here, our trend for atomic radius is down like this. Magnesium is further to the left, which will be larger than silicon, which will be larger than argon. So from biggest to smallest, magnesium, silicon, argon. So that answers the first question, Mg, Si, Ar. For the second question, it's a little bit different. We have neon, F minus, and F. So we're essentially looking at these two. Please ignore we're no longer looking at these. So I'm going to put maybe 2 stars, I guess, in order to identify these ones. So we have neon, F, and F minus. So now we have an ion, which is a little bit different. Well, F is definitely larger than neon. But what about F minus? How does it compare to the size of F? Well, F minus has an extra electron. So it's got 9 protons, but 10 electrons. So essentially we have the electron configuration of neon, but we have 1 less proton pulling on that, which means that negative ions are actually bigger than the neutral fluorine. So F minus will actually be bigger than F. So F minus comes first, followed by F, followed by Ne, and again, these just follow the traditional rules. Fluorine is more to the left than neon, so therefore fluorine is larger than neon, but F minus is actually larger than F. Note that if you had a positive ion, it would actually make it smaller. Let's look at the third case. We have Cl, Br, and Br minus. So we're here. I guess I'll put 3 stars for this one. Cl and Br and Br minus. Well, bromine is definitely bigger than chlorine because it's lower on the periodic table. Remember, the trend is down and to the left. So bromine is bigger than Cl. But what about Br or Br minus? Well, Br minus has an extra electron, which means you'll have 35 protons pulling on 36 electrons, and Br minus will be larger. Again, negative ions are larger. You could also consider this as the valence electrons. You have an effective nuclear charge here of about 7, and it's pulling on 8 valence electrons, so therefore it's larger. At the end of the day, the largest ion is Br minus, followed by Br, followed by Cl, and again, Br is bigger than Cl because it's lower on the periodic table and has another shell of electrons, which makes it larger.